In this video, we talk about galvanic cell or a Voltaic cell. The galvanic cell and the Voltaic cell are both the same thing, okay? So, we will learn how to construct galvanic cell and how it works. We will learn all the things in the single video, okay? So now let's start. First of all, what is a galvanic cell? What is the definition of the galvanic cell? The main purpose of the galvanic cell is the devices that use the chemical reactions to create electricity, okay? Such device that use a chemical reaction to create electricity, that device is called a galvanic cell or a Voltaic cell. We can also say that such devices that convert the chemical energy to electrical energy, that device is called a galvanic cell, okay? And now we daily see in our daily life, we use the galvanic cell. Like a battery is an example of a galvanic or a Voltaic cell. In the battery, there is a chemical here, and the chemical reactions are going in here, and that's why the battery works. Okay, it is also an example of a galvanic cell, like a Daniell cell. It's also a galvanic cell. We will talk about this later in the end of the video. Okay. So, what we learned till now, devices that use a chemical reaction to create the electricity, that device called the galvanic cell, and we use the battery is an example of a galvanic cell in our daily life. Now we see how to construct the galvanic cell by step by step. First of all, you have to take a beaker. You have to take a two beaker. First beaker have the ZnSO4 solution. You have to make a ZnSO4 solution, and then you have to make a CuSO4 solution, right? Okay. Now the solution has been made. Now what we have to do? We have to put this is a piece of a zinc metal. Okay. This is the piece of a zinc metal. We have to insert the piece of a zinc metal into the ZnSO4 solution, and then we have to put the copper piece in the CuSO4 solution, right? This is the copper metal piece, and this is the piece of a zinc metal. Now we what to do? We have to connect them by the wire. We have to connect them by the wire, okay? Like this. This is the ZnSO4 solution, and this is the CuSO4 solution. And this one is a piece of a zinc metal, and this one is a piece of a copper metal is inserted into respective solutions. Now I have connected the wire, connecting both them by the wire. Now what we see? What will happen? We have seen that after connecting the wire, the electrons are flowing in this direction. The electrons are flowing in this direction. The electrons are flowing in this direction. Okay? Right? The electrons are moving in this direction. After the connecting wire, we have seen that the electrons are moving in this direction. It means that, and we also know that the moving electrons makes electricity. This is the basic concept. Moving electrons, moving charges makes electricity. That's why here we have seen that the electrons are moving in that direction. It means that there is 100% surety that the current will be produced here. Now, suppose if I put here a bulb here, if I put here a bulb like this is a bulb, and then we will see that the bulb glowed up. What does it mean? It means that the current is here. Okay? Now we have to learn. Now we have to see what's happening. What's happening there is at the atomic level in the system. Okay? This is the basic system of the galvanic cell. Now we see how it works. So to knowing that how it works, we have to magnify the system. We have to zoom the system, and then we have to analyze how it works. Okay. So now let's start to magnifying the system, and let's see what happening at their atomic level, what happening up to the zinc atom, what happening up to the zinc Zn2 plus ions and the Ca2 plus ions, what happening there in the reality. So we have to magnify it. Now let's magnify. Before magnifying, I want to include one thing also, that here we also use here salt breeze also, okay? In the galvanic cell, we use a salt breeze in this, okay? But we will talk about the salt breeze in the end of this video. Now, let's them make simple. We are not using here salt breeze, so this is the basic system of the galvanic cell. Now, let's magnify. This is the magnified view of the basic galvanic system. Now, let me explain what is this. So, this one is the zinc. This is the zinc solid, and means it's a zinc metal piece. And here, and this Cu is a copper metal piece, okay, that we have inserted in the solution, okay. This is the zinc metal piece, and this is the copper metal piece, and this is the ZnSO4 solution, and this one is the CuSO4 solution. So now, and this is the Zn2 plus ions in the solution, and here Cu2 plus ions in the solution present. But we obviously know that here SO4 2 minus is also present here, and SO4 2 minus is also present here. It's already known, okay. That's why I am not showing here SO4 2 minus to make them simple, okay. So in the solution we have a zinc metal, and in the solution we have a copper metal, and this is the ions Zn2 plus, Zn2 plus, Zn2 plus, and this is the ion of the Cu2 plus. Now, and we have connected them both by the wire. This is the wire, okay. Now what will happen? Now let's start by basic. So first of all, here is a zinc, here is a zinc, here is a zinc, and here is the copper. And in the solution, there is a Zn2 plus ion, and here is a Cu2 plus ion. So now, it's a like of a war between the Zn2 plus and the Cu2 plus to take the electrons. So, who will win? Between the Zn2 plus and the Cu2 plus, the electron gaining tendency of the Cu2 plus has a strong pull for the electron, and the Zn2 plus has the weaker pull for the electron. Zn2 plus has the weaker pull for the electron, and the Cu2 plus has the stronger pull for the electron. That's why Cu2 plus takes the electron first, okay. Cu2 plus takes 2 electrons from zinc. That's why I have make a point here that Cu2 plus has a strong pull for electron, and the zinc has a weaker pull for electron. That's like of a tug of war between the zinc and the copper ion. So like in the joke, the copper saying zinc, "Hey zinc, give me your 2 electrons." Zinc said, "Oh yeah, okay, I am giving." Like poorly said, "I am giving," because zinc is weak. Zinc has a weaker pull of electron, and the copper has a strong pull of electron. That's why the copper ion pulls the electron from the zinc, okay. So what will happen now? Now we know that the zinc has a weaker pull for electron, and the Cu2 plus has a stronger pull for electron. So now let's what happen next. First of all, this is the zinc here. So zinc will lose 2 electrons. Zinc will lose 2 electrons, and after that, the losing the 2 electrons, it will become zinc to Zn2 plus. Now, how this happen? Now let's see. This is the zinc here, right? This is the zinc here. Okay, this is the zinc here. Now, zinc gives its 2 electrons. This is the 2 electrons. Zinc gives 2 electrons, okay, and it becomes Zn2 plus. It becomes Zn2 plus, okay. Zinc has given the 2 electrons. Now it becomes the Zn2 plus, and the 2 electron is here. And we also know that neutral atoms make up the solid metals, and the metal ions can usually dissolve in the water. So here what happened? First of all, this zinc is losing her 2 electrons, and after that losing, it will become Zn2 plus. Okay, and now we know that the metals ion can usually dissolve in the water. That's why this Zn2 plus goes in this solution. Okay, and now this 2 electron is going here, and this 2 electron is going here, and by the wire it will goes here. Okay, by the help of wire it will goes here. This 2 electron is going this side, this side, this side, this side, this side on the wire, through the wire, and this 2 electron goes here, and now it becomes this 2 electrons is going this in the solution, and the C2 plus makes them. Okay. Now we know that the Cu2 plus is a positively charged 2 plus charge, and here the 2 electrons, so now the Cu get neutralized. And we know that the neutral atom make up the solid metals, and that's why this Cu2 plus makes this Cu2 plus becomes, this Cu2 plus takes the electron like this and become as a Cu. Okay, this is the solid. This is the solid. Now we see. Okay, so here the Cu2 plus have taken the 2 electron and become the Cu, and this Cu get deposited on the metal piece of the copper. Okay, now see, again this Zn will lose her 2 electron, this one 2 electron, okay, and this Zn will convert into the Zn2 plus, okay. The zinc has been converted into the Zn2 plus after losing the 2 electron, and we know that the metal ion can easily dissolve in the water, and this Zn2 plus goes in the solution. Okay. Now this 2 electron goes here, and through the wire it will goes here, and this 2 electron will goes here, and this 2 electron reach at this side, and it will goes here, and this Cu2 plus ions in the solution will goes here, and it will take the 2 electron this. Okay, this will take the 2 electron, and now it becomes a copper solid. This is the copper solid, because neutral atom makes up the solid metals. That's why it will get deposited on this metal piece of the copper. Now, then again see. Again we do the same experiment. This is the zinc. One more experiment left. Okay. This is the zinc. It will again losing her 2 electron. It will become Zn2 plus, and this is the 2 electron left, and this will become here Zn2 plus. Okay. This will become Zn2 plus. And now we know that the metal ion can easily dissolve in the water, and that's why it will go in this solution. Right? And this 2 electron goes here by the help of the wire. It goes here by the help of wire, this going and reach this side. Okay, reach this side. This 2 electron reach this side, and then in the copper 2 plus in the solution, it have the stronger pull for the electron. That's why it will take the 2 electron and become the neutral Cu like this. And this Cu will get deposited on this copper metal piece. Okay, copper metal piece. Right? So this is the basic mechanism of the galvanic cell, how it happens at the atomic level, what happens to the zinc atom, what happens to the copper atom, and what happens to the zinc ion, and what happens to the copper ion. Now we have all seen the concepts, now we have all seen the mechanism, how it works. But now very much things are left to explain here. Now let's explain some other things. Okay. What will happen here? Actually here what happened? After the zinc goes in the Zn2 plus as in the solution, here is a, let me remove this. Here is an excess of positive charge buildup. Okay. In this solution, here is an excess of positive charge builds up of the Zn2 plus, and in this solution, CuSO4 solution, and here we have not shown here SO4 minus. This is the SO4 minus 2 solutions here in the aqueous solution, but this is the SO4 2 minus. Okay, this is the SO4 2 minus. Now let's zoom it. You can see it clearly. Okay, this is the SO4 2 minus. So all the Cu2 plus in the solution will make solid here. Okay, so only in the solution SO4 2 minus has been left in the excess, and in the solution Zn2 plus is excess in the solution. So there is something like not a balanced charge. In this case, the positive charge builds up in the solution, and in that case, the negative charge builds up in the solution. Okay? Here in this case, the negative charge builds up, and in this case, the positive charge builds up in the solution. So we have to neutralize it. So we have to let them neutralize, because after the neutralizing, the battery or the cell works properly. Okay? So to maintain the electroneutrality principle, we have to use here a salt breeze concept. Okay? The salt breeze concept, right? We have to use salt breeze. This is the salt breeze. This is the salt breeze. Okay? Salt breeze is actually, what is this? Salt breeze is like a tube. It contains a strong electrolyte like a NaCl with the same ionic mobility of the ions, like in this case the Na plus and the Cl minus have approximately the same ionic mobility. That's why it is a suitable electrolyte for this salt breeze. We have taken here NaCl, and what is the work here? And what is the work of this salt breeze? See that actually in this solution, the excess of a positive charge. Okay, here is a Cl minus. We have to add more ions. Okay, we have to add more ions, right? Then we can explain very simply. If we add here, this is the Na2 plus and this is the Cl minus. Okay, now this is the complete salt breeze. So what will happen here? What's the work of the salt breeze here? Now explain that this is the Zn2 plus and excess in the solution. So we have to neutralize these charges. That's why the salt breeze containing the ion Cl minus comes slowly into the solution and make them with the Zn2 plus. Now the charge is neutralized. Okay? And in this case of this side, here is the SO42 minus is in the excess to neutralize the minus charge. Here the Na plus sodium ions comes slowly into the solution and make them with the Na2SO4, and then the negative charges get neutralized. That's the use of a salt breeze. To maintain the electroneutrality of the cell, we have to use the salt breeze. That's why the battery or a cell works efficiently, works properly. Okay, that's the main reason to use the salt breeze in the galvanic cell. That's a very important concept here of the salt breeze. We cannot take any electrolytes in this salt breeze. We only take a strong electrolyte and having the same ionic mobility of the cation and the anions. Because with the same rate, it will neutralize the positive charge and the negative charge. That's why we need a same ionic mobility of the ions in the salt breeze. This is the concept. Now our time is to write a chemical reaction in the chemistry format, in the reaction format. Okay, so here in this case, the zinc becomes Zn2 plus after losing the 2 electron. It's a half cell reaction, and here the Cu2 plus taking after 2 electrons becomes a Cu solid. It's also a half cell reaction. So what happened in there, in the chemical form, actually here what happened, this Cu2 plus in the solution takes the 2 electron and became the Cu solid. This is the Cu solid. Okay? And in this case, the zinc solid is converted into the zinc 2 plus. By losing the 2 electrons, it will become Zn2 plus. This is the chemical reaction. This is the half cell reaction of this cell, of this, and this is the half cell of this. Okay, and we say that the piece of a copper is called cathode. The piece of a copper is called cathode, and the piece of a zinc is called anode. Right? Piece of a copper is called cathode, and the piece of a zinc is the anode. And we also know that the losing of electron is called oxidation, and the gaining of electron is called a reduction. And here the zinc is losing its 2 electrons and becoming the Zn2 plus. Here is oxidation occurs. We say that at the anode, the oxidation will occur. Right? But in this case, the Cu2 plus gain the 2 electron and becomes Cu solid. In this case, the reduction is going on, and we can say that at the cathode, the reduction is happening. Okay? The reduction is happening. Now let's see. What is this is the half cell reaction of the anode, and this is the half cell reaction of the cathode. We have to now make the net ionic equation. The net ionic equation will be like this. This is the net ionic equation. Cu2 plus Zn solid, it becomes Zn2 plus Cu solid. We have add this together, the 2 electron and this 2 electron will get cancel each other, and the net ionic equation will become this. Cu2 plus zinc, it will become Zn2 plus Cu solid. This is the basic system of the galvanic cell. We have learned here how it works, how we construct the galvanic cell in this video. I hope you all like this. And so, okay. One thing left here, that we are saying that here the zinc will decompose and it will go in the solution, and here the ions will get in the solid. The thickness of this cathode, this piece of the copper, will get increased, but here the thickness of the zinc piece of metal is getting decreasing because the zinc will get decomposed in the ion in the solution form, but here the ions will get in the solid form. So it means that after the process happening here, the cathode sizes become larger and the anode sizes become smaller, like this, because this is the actual starting form of the reaction, okay? But after the happening reaction, the zinc metal pieces gets decomposed. We have to interchange here because it's a zinc electrode and it's a copper electrode, right? It's a zinc electrode and this is the copper electrode, okay? This is the anode and this is the cathode. But this is the actual starting reaction. We have seen that the same size of the cathode, but after the reaction happening, what will happen? The zinc will get decomposed in the Zn2 plus ions, and the thickness and the zinc anode is becoming smaller. And in the same time, the cathode electrode of the copper, it will become larger in size. How? Let's see. This is the zinc electrode, zinc metal piece. Now it will become like this. Yeah, very teeny size, like it's very small, okay, because it decomposes into the Zn2 plus ions in the solution. And here the copper will become like this. It will become fat. This is the actual difference. Here. After the reaction happening goes on, the zinc anode, it will get smaller, and the cathode will get, the size of a cathode is larger, because the Cu2 plus in the ions will make up in the Cu solid. That's why the Cu solid goes on the metal piece and it will increase the size of the cathode. But here in this case of a zinc electrode, the zinc goes in the Zn2 plus. After losing the 2 electrons, it will go in the solution, and that's why there is a deterioration of the zinc anode. Okay, that's why in the process is going on. Okay, this is a basic concept of the galvanic cell. We have seen that. This is the basic concept of the galvanic cell. I have explained you in the very lucid manner, in very simple manner, in very experimental manner, how it works, how we construct the galvanic cell. And I hope you all love this video. Thank you so much for watching my video, and please subscribe this channel for more videos. Okay, so thank you very much. Bye bye. Shukriya tahe dil se.